This is an example of an applied problem with a few more constraints than what we're used to working with. Spice It Up sells ground turmeric for $1.35 per ounce and ground sumac for $1.85 per ounce. Ethan wants to make a 20-ounce seasoning blend of the two spices that sells for $1.65 per ounce. How much of each should he use? So what we have going on in this problem is we have a certain amount of ground turmeric, which sells for a certain price, and a certain amount of ground sumac, which sells for a different price. And we want to make a blend, 20-ounce seasoning blend, that sells for $1.65 per ounce. There's a lot of information going on in here, and there's also a lot of questions. Oh, no. There's one question. How much of each should he use? I suppose another question is why he's blending on price versus on taste, but how much of each should he use is what we're trying to answer. Since that means we're going to find the amount of turmeric and the amount of sumac, we're looking for two things. Those two things drive your variables. If we were looking for three things, we would need three variables. And also, the number of variables equals the number of equations that we need to work with. So since this is going for two variables, there's two equations we want to build. The basis of those equations should be the type of thing that we're talking about. So we're looking at two things here. We're looking at a total number of ounces or some combination of ounces. And then we're also looking at price per ounce. So a dollar amount. We're looking at ounces and dollar amount. Let's start with our variables and build our equations based on the units. Since we're talking about turmeric and sumac, I'm going to say let T equal the number of ounces of turmeric and let S equal the number of ounces of sumac. For the equations, I want one equation having to do with the number of ounces. So since T is the number of ounces of turmeric and S is the ounces of sumac, I know that T plus S together should equal the total number of ounces. That should be 20. I also want an equation about dollar amount, where I'm including this information about turmeric being $1.35 per ounce and so on. So if turmeric's $1.35 per ounce, I know that for each ounce of turmeric, it's going to cost $1.35. So if I have two of them, that's going to be 1.35 times 2, or 2.7. Same thing with sumac, 1.85s. And on the other side of the equal sign, I want to figure out what the total cost is for that 20-ounce seasoning packet. So what I'm going to do is I'm going to do 1.65 times 20. One thing I forgot to mention earlier, when defining the variables, be really specific. I'm not just saying let T equal turmeric. I want T to be the number of ounces of the turmeric. So there's our two equations. Let's go and solve them. I'm choosing to solve them using the elimination, also known as the addition method. To do that, I want these coefficients, either with the T or with the S, to line up to be exactly opposite one another. That way I can add the equations together and have one of the variables cancel out. So what I'm going to do to get these to be opposite one another is I'm going to choose to eliminate the T's. And so I'm going to multiply this second equation through by negative 1.35. I have to multiply both sides of the equation for this to work. So I'm going to copy down my first equation, 1.35t plus 1.85s equals, what is that? 33. And then the second equation becomes negative 1.35t minus 1.35s equals, what is that, negative 27? Equations together. Notice that when we add 1.35t with negative 1.35t, that adds to 0. 1.85s minus 1.35s turns into 0.5s. And on the other side of the equal sign, 33 minus 27 equals 6. Solve for s. S equals 12. So that tells us that there's 12 ounces of sumac. We also want to find how many ounces of turmeric. I know that T plus S together equals 20. And so if S is 12, subtract 12 on both sides, get T equals 8. So that's 12 ounces of sumac and 8 ounces of turmeric. There we go.